Hey guys, I'm missing y'all. I got a little message for you.
Night on the streets tonight, the lights are growing dim. The walls of my room are closing in. But it's good to see your smiling face and to hear your voice again.
Tearing up, guys. I long to see your smiling faces and to hear your voices again. Missing y'all. Let's look at extrema and intervals of increase and decrease. Maybe we'll feel a little bit better. A local and absolute maxima. And I like to think of this in terms of in Mount Mitchell, North Carolina. Mount Mitchell is the highest point in the United States east of the Mississippi River. And that's where this picture is taken from. So it's taken from the vantage point of the highest point. And you've got all these other points. This is a really nice place to visit, by the way, if you want to do something this summer or sometime. But all these other points or peaks are local maxes. And Mount Mitchell is the maximum, the highest point. And it is that simple. Let's don't make it hard. So that's not Mount Mitchell because we have points over here that are higher than this piece or this peak right here. It's a peak, not the peak, not Mount Mitchell. Let's move on. The plural of maximum is maxima. Little piece of trivia there. But a maximum, whether it be local or absolute, causes the function to stop increasing and start decreasing. Think of yourself or Steve as hiking up this mountain. He gets to the point, oh, Steve was linked. Let's change Steve's color. And you get to the top and then you get to go back down. So Steve is happier on the way down. And then that's just Mount Mitchell there. We call Mount Mitchell the absolute maximum. There's no other higher point. And again, it causes the function to stop increasing and start decreasing. Well, a minimum is kind of the same thing. You have locals and absolute. This is locally the smallest point, but we have points on the graph that are lower than it. And it causes the function to stop decreasing and start increasing. It's like a valley. You're like, oh man, I got to start hiking up again. And the plural is minima, not minimums. And then that was an absolute minimum, kind of like the Mount Mitchell of valleys, the Mitchell Valley. And then not much to say there. Stop decreasing, start increasing. A word that encompasses all of these concepts is extrema, whether they be local or absolute, a minimum or maximum. Now, there is this other thing called an inflection point, and it is an awfully interesting point, but it does not cause this function to stop increasing here. All right, it is curved downward here and curved upward here, so it changes concavity. And again, it is interesting, and I will throw it at you, but we are going to have to ignore it. All right, let's move on. Intervals of increase and decrease. Intervals of increase and intervals of decrease are vertical questions answered horizontally. In behavior, when we do it or if we have already done it, reverses that. It will be a horizontal question answered vertically, but we're not doing that today. Let's don't worry about it today. So what we want to do is trace the function left to right. So let me do this. All right, I traced the function left to right, and clearly the green intervals are going up and the blue intervals are going down. Up, down, up. And so let's put in some coordinates for our local minimum, maximum, coordinates for our local minimum, and, let's throw some coordinates in on this inflection point right here. We're going to have to ignore it. Now, let's put in the endings. Since that ending goes right forever and up forever, they're both infinity. So it's possible in a case like this where you pick the wrong infinity but still get it right because they're both positive. And we have the same thing on the other end right there. That goes left forever, and then it's also going to go down forever, and they're going to both be negative infinity. So you could pick the wrong one and get it right. And so what you want to do is X out all the vertical concepts because it's a vertical question. And then you also want to X out this one because that is not an extrema, not extrema. And then you name your interval that you want to name. We want to name the interval of increase here. An abbreviation, again, is IOI. See if you can do that. At Socrative, this is number 1. So if I refer to number 1, that's what I mean. And you would type all of this right here. It increases from negative infinity to 15. And then we have another piece where it increases from 22 to infinity, and then put a U between them. And I'll give you some directions at Socrative. That's a lowercase u. No spaces. Remember, don't hit the space bar. I can't account for that. All right, see if you can write the interval of decrease that only decreases once. And that would be 15 to 22. Well, this is math class, so let's do another one. I mean, we never do just one. So we want to trace, let's put in the endings first. Now, these endings are more tricky because it goes left forever here and up forever. Now you have to pick the correct infinity to write your intervals. And the same thing here. This goes right forever and down forever, right forever, down forever. And you have to pick the right one. All right, then we want to trace the function. Don't deny me this. This is so much fun. And we have multiple intervals of increase and decrease. And we want to X out the vertical concepts or the vertical coordinates and answer it horizontally. It's a vertical question, answered horizontally. See if you can name that. We're doing the interval of increase here. And there's your answer. -6 to 8. Union 16 to 24. All of that. So again, that was number 3. And at Socrative, that's what you would type in. Let's just answer that one right here. You may want to pause the video and see if you can write this interval. X out the vertical coordinates or concepts and answer it horizontally. So it begins here at negative infinity. It ends at -6. Union 8 to 16. Union 24 to infinity. I do want to point out that we're not going to use brackets in these intervals. I've seen it done that way, but for simplicity, let's just use parentheses. Some of you are probably thinking about that. Let's move on. I think this is the last function. We do have an interesting piece right here that's constant, and we would ignore it. What type of interval is this? It's a constant interval, and so we would ignore it. And then we would trace the function left to right, and so you can see what's going up and going down. And we put in the endings, and then let's X out what is not needed, and then see if you can write the interval of increase. I believe that would be negative infinity to negative 18, union 14 to 17, union 20 to infinity. Don't hit the space bar. Lowercase u for union. Might want to write some of these answers down. All right, see if you can do that. Pause the video. There's the answer. All right, that was a lot of fun. We talked about extrema. We talked about intervals of increase and decrease. I think we have a cameo appearance. It is Bruce Springsteen who sang you your little message at the beginning of the video. Thank you, Bruce. And then let's do some more questions. All right, may want to pause the video as we do these. Going up or down, that is going down because you have to go left to right. Number 8, up or down, that is down because you got to go left to right. These are some questions that you'll see. Number 9, that's going up. You got to go left to right. You got to ignore the arrow there. That doesn't have anything to do with it. Number 10, which is a point where the graph stops decreasing and starts increasing. So that would be point C. Number 11, which point changes the concavity of the graph but not its direction. That's the inflection point B. Number 12, which describes point P, another inflection point, changes its concavity. 13, we're getting close to the end here. Point P is a local minimum. 14, point P, that's Mount Mitchell. That's the absolute maximum. 15, how many intervals of increase are in the following function? It's a good question. I want to pause the video and see if you can come up with that. 1, 2. 2 goes up twice. That does not cause it to stop increasing. I think this is the last question. How many intervals of increase are in the following function? All right, so we're sort of the same thing. Pretty uncreative of me, but that's okay. 1, 2, looks like 2 again. But just want to see if, look, we're not going to do that. We're not going to have 2 cameos. We're just going to have 1. Just wanted to see a couple of questions that we'd be answering. All right, guys, that went long. Sorry about that. See ya.